Here are some examples using the law of logs to expand them out. The first one says the log of x squared y. Now this can or cannot be, it doesn't have to be in parentheses. See, this one has the parentheses around it. Here they don't, but that's the input. So you could put the parentheses around it like this if you'd like, right? Alright, so I'm going to use, I see a product in here, so I'm going to use the product rule. Things are being multiplied together, then they're split up as a sum like this. You see that? So I'm using the product. So the m is on the inside and the n is on the inside multiplied together. I split it up as two separate logs. So the first step is to split them up that way. Log of x squared plus log of y. Okay? Then the second rule, we see this little squared symbol on the x, right? So that's the power rule. If you have some value m raised to the p power, the p can actually come down in front to be a multiplier on the outside. And notice it has to be to the whole input. So this p is on the whole input. That's why I couldn't do the 2 first, because the 2 wasn't out here. If the 2 was out here, that would first have to come down and then split up. Okay? So now I rewrite it like this. The 2 comes down. 2 log of x plus log of y. And this would be the answer. Okay. The next one here, the natural log of e cubed over 7. So parentheses, they have them in here for us. Again, the 3 doesn't come down because it's not on the outside here. You have to split them up first, and this is the quotient rule, right? It's division, so it comes out as subtraction. So I say the natural log, anything in the numerator is positive, okay? E cubed, and anything in the denominator always has a minus natural log and then 7. That's where if you have more than one thing in the denominator, there'll be another minus something, okay? Things in the numerator are positive out front. Then we have to bring that 3 down. So we take that and move it down to the front. 3 natural log e minus natural log 7. But what is the natural log of e? Right, that's just a 1, right? So this is 3 times 1 minus the natural log of 7, or 3 minus the natural log of 7. Let's move on to another example here. It's the log base m, or the square root of r cubed over 5z to the 7th. Okay, well, it's a little tricky, isn't it? But let's change, we know what square roots are as exponents, right? So I change it to log base m, and I'll put parentheses around that. R cubed on the inside, 5 times z to the 7th on the inside on the denominator. And what would be the exponent? Right, the 1/2 power. Okay, now notice that 1/2 power is on the outside. There's two things you could do with it. You could use a power rule right away, bring it out front, and then split this stuff up. But keeping in mind that the 1/2 multiplies all of the log, or you can bring the 1/2 in into each of these guys. I tend to do that. So what I'm going to do is just send the 1/2 in as an exponential rule like this, the distribution portion, right? So I go log base m, and it's going to be r to the 3 times 1/2, or 3/2, 5 to the 1/2, z to the 7/2, and then I split it up. So that means the first log is the positive one here, right? So log, can't bring things down, you got to split them up first now, since I sent it in there. R to the 3/2 with a base of m. Then now these things are in the denominator, so minus log each one of them. First one's a 5 to the 1/2 with a base of m. Then there's another thing in the denominator, so it's minus log z to the 7/2 with a base of m, right? Now I have all these exponents here that can be dealt with the power rule. They need to be brought down out front of each of those. So 3/2 times log base m r minus 1/2 log base m of 5 minus 7/2 log base m of z. And this would be the answer. Now, if you were to bring the 1/2 out front first, The only difference is the 1/2 would be factored out of these guys. So this would be an acceptable other answer. The 1/2 would be on the outside, and you would have 3 log m r minus the 1/2 is a factored out log base m of 5. 1/2 is factored out, so it's 7 log base m of z. So that's another acceptable answer, but you see how the 1/2 has been factored out in front of each of these logs, right? And that was what would happen if you would have did the 1/2 first outside like that. So either of them are acceptable answers. Now what I'd like you to do is pause the video and see if you can complete these two. See if you can expand these two using the rules that you see. Alright, hopefully you had a second to do that. Let's continue and expand this one out. Log base 4 of 16 over 7x. So, again, I think of it like this, right? Numerator and two things in the denominator. So this would be log base 4 of 16. That's the only thing in the numerator. And then two things in the denominator minus log base 4 of 7 minus log base 4 of x. Well, we know this over here, right? So this isn't, we're not done here. We should change this. So this asks the question, 4 raised to what power is 16? That's what this says, right? So this is actually 2. 4 squared is 16, right? So this is 2 minus log base 4 of 7 minus log base 4 of x. So this is the answer you should have for that one. A little tricky there. Alright, then what about this one? Well, we start with that one. We have the square root, kind of like I had before, right? So maybe I'll change it to the natural log of z over 3r squared, and then all raised to the 1/2 power. Okay, now like I like to do, I distribute the 1/2 to each of those, okay? So I'm going to keep doing it that way because it's just an exponential rule. You distribute to each of those, okay? So now I have the natural log of z to the 1/2 over, keep things in like this so you can see it, 3 to the 1/2, and, well, 1/2 times 2 would be just 1, right? So r to the first power. Alright, then we have to split that up. So the z to the 1/2 is in front, so that's positive, right? Or up top, and it's positive, so natural log of z to the 1/2. These two are in the denominator, minus natural log of 3 to the 1/2. Another minus, because there's another thing in the denominator, r. Move down just a little bit. Now I bring out the 1/2 in front of these two, right? Which would be 1/2 natural log z minus 1/2 natural log 3 minus natural log r, and that's it. Doesn't look like anything else could be done. Well, hope those examples helped, and I can move on to condensing the logs.